Hello everyone, today I'm going to talk about question 5. In this question, you have one block that will be pulled by a certain amount of force, and the given weight of this block is 50, and the normal force we're gonna find it in this question. Okay, this is the block, and this is the force that exerted on the block. The degree for this block and we pull is 50 degree. The theta is 30 degree. The weight of the block, I'm gonna put it here, and the weight is 50 kilogram. When there is weight here, and we're gonna put normal force here, and we're gonna put it as NC. Okay, we have another one to put in this free body diagram. Here is free body diagram. Step number 1, and opposite to the force here, we're gonna put the frictional here. Frictional force is 0.2 times normal force. That is step number 1. Step number 1 is free body diagram. Okay, in the question, they ask us to find the P and C. So the step to find P and C here, firstly we gotta find the acceleration of the box. The first one, acceleration. How do we gonna get the acceleration? By using the kinematic equation. So kinematic equation has 3. We're gonna use only one, that is which is v squared equal to v naught squared plus 2ac s minus s naught. S is distance, so we just put the given that had been given the equation. As for the v is given as 10. The v naught is not stated, so we gonna say rest. So we're gonna say it's 0 because it start from rest. Plus 2, acceleration is what we gonna search, and the distance here is 25. So when it start from rest, so we just assume the distance is start from 0, so 25 minus 0. So the acceleration here is gonna be 2 meter per second squared. When we got the acceleration here, then we can continue with equation of motion. Equation of motion here, we have x-axis and y-axis. X-axis and y-axis. So we're gonna start with y-axis. Summation of Fy equal to MAY. So in this block, in this in this block stated that in the y-axis we have the wake, and the normal force, and the P here is force. We're gonna resolve it to the y-axis. So we're gonna state here normal force minus 490.5. This is when you times 50 with 9.8. 50 times 9.8. Why 9.8? Because it is gravity. And the next one is force. Force, when we resolve in y-axis, we're gonna state it is as sine 60 degree and equal to 0. And equal to 0. Why equal to 0? Because acceleration in y is 0, because the block only move on the x-axis, so the acceleration in y is 0. So when 0 is times by the mass, it's gonna be 0. So you resolve it in normal force. Put normal force as the subject, and the other side we're gonna just put the number 0.866 p, because this is when we resolve sine 60. Okay, the next one, we're gonna resolve it. In summation of x. Summation, we assume it to the right is positive. Okay, here and x, acceleration in x. So we resolve everything on the FBD to the x-axis. So we're gonna get 0.2 normal force minus force, and we resolve in the x-axis, which is cos 60 degree, equal to 50 is the mass. 50 is the mass of the block, times by -2. -2 because the acceleration in this direction, so the opposite direction is negative. So here, where we got to the previous kinematic equation that we get. So the normal force here you get from the previous one is 0.2 490.5 minus 0.866p is 0.5. Close the bracket. -100. So here we only have the force that has been the subject. So we're gonna resolve it. So the P will be 294.27 Newton. So the force that we gonna find, that we already got the force here, but it's not the final answer yet. We still need the normal force. So the normal force, you're gonna the previous equation is not resolved yet because it has two unknown. So the previous equation is this. Is actually P here. is when we put inside, it's gonna be 294.27, and you resolve it, and you got the normal force 235.66 Newton, and that's the answer. Okay, next question. In this question, we have a person that ride a bike. So the FBD, the first step, we have to draw the free body diagram. The free body diagram, we have two wheel here, the front wheel and the back wheel. Okay, this is a bike right here. Okay, this is front wheel. We're gonna find the normal here and normal here. So we're gonna state it NA and NB. So there is a person here. Person riding a bike. With a mass of 50 kilos. 50 kilos, when you time it with a gravity 8.91, it's gonna be 490.5 Newton. And here is the G1, and this is G2. G2 is the weight right here at the person, and the G1 is a weight of the bike. Sorry about my drawing. And the weight of the bike is 30 kilogram. And when you want to convert it in force, you gotta time it with the gravity, and it's gonna be 294.3 Newton. So we have distance here, here to here, here to here, and distance here, the bike, and the leg to the back wheel. So the distance is 0.4 meter. This is also 0.4. This is 0.2. This is 0.4 also. So the distance of the bike is 1.25 meter. So our body diagram, our free body diagram is complete. So the next step, we're gonna find the normal A and the normal B at the front and the back wheel. So the front wheel, we're gonna use moment. Motion. Okay, the moment we assume positive moment, the anti-clockwise summation. Okay, here. So you state the moment, every moment on the free body diagram. So it's gonna be NB positive minus 490.5 times 0.6. 0.6 is the plus of 0.4 and 0.2 minus 294.3 times 0.4 and equal to 50 times by 5 and times by 1.25. 1.25 is the height of the bicycle, and minus 30 times 5 times 0.4. 0.4 is the height. Okay, so we have one unknown here. We can solve it, and it will be the normal here is going to be 39.52 Newton. So you got the back wheel. So for the front wheel, you will use equation of motion. Sorry. Motion at y-axis. At y-axis we have NA plus NB minus 490.5 minus 294.3 equal to 0. So the previous one we get the NB. So the NB we're gonna put in this equation, so it's gonna be NA plus 39.52 minus all the above, 490.5 minus 294.3. So we can solve this equation. It's gonna be NA equal to 745.28 Newton. So you got the NB and the NA, so the equation is solved.